Sewage systems and aqueducts have been essential infrastructure for civilizations throughout history, providing access to clean water and safe waste disposal. Aqueducts were first developed in ancient civilizations, with the earliest known aqueduct dating back to the Assyrian Empire in 1691 BCE. The ancient Greeks and Romans also developed an elaborate aqueduct system to bring water into their cities for drinking, agriculture, and public baths. The Roman aqueducts in particular were a remarkable engineering achievement, with some of these structures still standing today. The sewage systems, on the other hand, are a far more recent development. In medieval Europe, waste was often thrown onto the streets or into rivers, causing widespread pollution and disease. It wasn't until the 19th century that cities began to develop underground sewage systems to manage waste. The first large-scale sewage system was constructed in London in the mid-1800s, and other major cities soon followed suit. Today, modern sewage and aqueducts continue to play a critical role in public health and sanitation. In many parts of the world, access to clean water and safe waste disposal remains a major challenge, and ongoing efforts are needed to ensure that everyone has access to these basic necessities. The development of the modern sewage system in the past had significant health benefits. Prior to development of modern sewage systems, many cities had no organised system for waste disposal, and waste was often dumped into rivers, lakes and other bodies of water. This practice led to the contamination of water supplies, which caused outbreaks of waterborne diseases like cholera, typhoid and dysentery. Installation of sewage systems helped reduce the spread of these diseases by providing a safe, effective means of disposing of human waste. Sewage systems prevented waste from being dumped into water supplies and instead directed it to treatment plants, where it could be safely treated and disposed of. The impact of these systems on public health was very significant. For example, after the London sewage system was completed in the mid-19th century, there was a marked decline in the incidence of waterborne diseases. Similar results were seen in other cities that implemented sewage systems. The development of sewage systems played a critical role in improving public health by reducing the spread of these diseases, and was an important step to providing sanitary living conditions for people in urban areas. Modern sewage systems are designed to collect, transport and treat wastewater sewage from homes, businesses, industrial factories and others. There's a general overview of how they work. Collection. The sewage is collected through a network of pipes and pumps that are designed to move wastewater from its source to the treatment facility. The collection system is usually designed to be gravity-based, where sewage falls downhill, or may use pumps to move the wastewater. Once sewage arrives in the treatment facility, undergoes a series of processes to remove contaminants and pathogens. The treatment process may include several stages such as screening, grit removal, sedimentation, biological treatment and disinfection. The aim of these processes is to remove as much organic matter, pathogens and other contaminants as possible, making the wastewater safe to discharge into the environment. After treatment, the wastewater is typically discharged into the environment, either into nearby bodies of water, onto land, depending on the local regulations and environmental considerations. In some cases, the treated water may be reused for non-potable purposes such as irrigation or industrial use. Modern sewage systems also incorporate advanced technologies to enhance efficiency, reduce environmental impact and improve the quality of the treated water. For example, some systems use renewable energy sources such as solar and wind power to power their treatment facilities. Others use advanced treatment technologies to remove nutrients such as nitrogen and phosphorus from the wastewater before it is discharged. These advanced technologies are helping to make sewage systems more sustainable and effective at treating wastewater. Modern aqueducts are designed to transport water from one location to another over long distances, using gravity to move water through a system of channels, tubes and pipelines. Here's a general overview of how they work. The aqueduct system starts with a source of water, such as a lake, river, or reservoirs. The water is typically collected and stored in a dam or other water storage facility. Once the water is stored, it is conveyed through a system of channels or pipes to its destination. The conveyance system is initially designed to be gravity-based, meaning that all the water flows downhill, using the natural force of gravity to move water through the system. The channels or pipelines are constructed of various materials, including concrete, steel, plastic, depending on the specific requirement of the project. Along the way, water may be diverted or redirected using control structures, such as weirs, gates, or valves. These structures help regulate the flow of water to ensure it reaches its destination in the desired quantity. In some cases, the water may need to be treated before it is used for its intended purpose. For example, if the water is transported for drinking water purposes, it may need to undergo a series of treatments such as filtration, disinfection, and chemical treatment. Once the water reaches its destination, it is distributed to its intended users, such as homes, businesses, or irrigation systems. Modern aqueducts are a critical infrastructure that helps ensure a reliable supply of water for a variety of purposes. They are designed to be efficient, sustainable, and effective at moving water over long distances, using the natural force of gravity to do the work.